Alrighty, well, what I got here is I poured out some navel jelly in my little dish here. Then I've got a toothbrush and an acid brush, and I'm just going to apply it carefully to the corroded surfaces. Try not to get it on all the wiring. These are cloth covered wires, which is pretty cool. However, they have that corrosion dust and everything's all over those wires too. But I don't want to put this on the wires. I'm going to try some lacquer cleaner, some lacquer thinner on that. I put this paper towel down here just to keep it from getting dripping down into all the other components and on the other part of the chassis there. I don't want to make a mess, you know, all over that thing. That would be such a drag to have to clean all of that up. You know, you get some stuff on stuff you don't want to get it on once in a while, and that's bad enough to have to clean that. But you know, if you can avoid it, shoot, man, cover it. You know, and this is the instructions are to leave this on 5 or 10 minutes. So I'm going to do that. You know, I'll put it on here and then wipe it off with water. Be careful around this. You know, ideally, it would be nice to take those things out, but to do that would involve desoldering everything on them, and then there's some retainer rings under there to hold them in there. Yeah, it would really be nice, because you know what, these leads in here, these connectors, pin connectors that are inside those sockets, have this corrosion on them as well. Okay, what did it say about getting it on brass? Let me see what it says. Use on steel, iron, and other ferrous metals. Do not use on aluminum, chrome, stainless steel, or painted surfaces. Okay, doesn't mention brass. I have some Brasso here that would clean up that brass resistor pretty good. I'm going to test it here, and after I clean all this off, before I bolt this puppy back down there, I am definitely going to clean that stuff off. I mean, I'll check the resistor, that is. I'm definitely going to check the values on that resistor bar. Then clean it up. Because like I say, I'm going to leave it in there no matter what. I'll leave it in there, even if I'm going to just detach it, because it's kind of like, you know, while this is not like this is a piece of test equipment, but it is, it's an interesting piece of test equipment. I bought it because I found it very interesting from a collecting standpoint. I think that it's wooden case, and the faceplate that it had, the black paint, the white paint, the fact that it uses the 6E Magic Eye tube and all that, just it was a cool piece of equipment. I thought it looked really cool, and I thought it would be fun to test capacitors with, although, you know, when I'm doing this kind of work, pretty much I'm taking out all these capacitors anyway, and I'm going to when I recap an old radio or something like that, I'm just going to recap it all, take out all the caps, and I don't really need to test them. But once in a while I may test a capacitor. But this thing will also test resistance, although the digital volt ohm meter would be better for that anyway, but it still would be a fun thing to have. I just didn't know all of the expense that would be involved in ordering those plus or minus 2% capacitors. Those things were outrageous. They were just outrageous. And I'll show them to you. Got them right here. I found them. Might as well cut them open. I haven't even cut open the packages. The only reason why these are even being made is that they're used in military avionic radios and stuff like that. So they run an extremely high tolerance, I guess, on their avionic radios, aviation radios, whatever they do. They want them to be precise. Here's one. This doodad right here is a 0.47 microfarad plus or minus 2% 100 volt capacitor. It is going to replace two of these. Okay, what am I doing? I only got one. Hold on a minute. Let me think. Just a 100 volts. Oh, I know. This one is going to go in parallel with the other, with this one. This is a 2.0 microfarad plus minus 2% 100 volt. And I'm gonna put them in parallel like so. And then it's going to replace a very large paper capacitor in here. See if I can turn this around so you can see it. That bad boy right there. Let's bring you a little closer in for that. You see that rather large paper capacitor right there, which is approximately 5 inches long and at least an inch in diameter. That is going to be replaced by these two capacitors here. Now, there's still one capacitor that is supposed to be a plus or minus 2%. And that was this 0.0115 microfarad 200 volt capacitor, which I believe it's a mica capacitor, and I'm not going to replace it anyway. C3 coming off of the R1 rheostat and going to this button bar down here on the end. Alright, and when I looked, I believe this might be it here. This might be the mica capacitor that's referring to. In which case, I mean, they don't usually go bad. It's too bad I can't use this to test it. This is the only one I have as far as the capacitance checker analyzer. It's the only one I have. And can't use it to test itself. I do have another one coming on the way. I won another auction for a rather cool capacitor analyzer, and I'll make another video when I go and do a restoration on it. And we'll talk about it a little more later. This is the Cornell Dubilier BF-50 capacitor analyzer. Now let's see what we've got here. I'm gonna wipe some of this down just to see how it went. Notice the color differentiation there. This white, I read up on this white corrosion. It is a booger to get rid of. It's just a real pain in the butt. It doesn't however, I've seen other people on YouTube that have used this to clean up white corrosion like this, and it looks marvelous. To me it doesn't look like it's doing much of anything. I'll try scrubbing it a little bit. I don't know. Wow. Apparently doesn't do much good to scrub with this naval jelly. Doesn't seem to do anything. I thought it'd work it down into those that white corrosion is like little crystals or something, powder, a fine powder. But I guess if you had a magnifying glass or something, they'd look like little crystals or something. I don't know, but I don't like that. I don't like it at all. It's some nasty stuff. And it has just covered everything from all of the cloth wire to the components themselves. And it was even lined that wood box on the inside. So, basically made a mess out of this whole unit. I'm going to put some more in it. I'm going to let it sit for a little longer. Hope lacquer thinner takes that stuff off all the wiring and everything. So I really don't want to do it now because I'm in the garage with the door shut. It's a little cool. It's been a little chilly here lately. And kind of need open ventilation. Start using that kind of stuff. I wonder if I should do more. I mean, I see these guys on there, they're doing, this is the first time I've done this. They'll do a small area and work around in there, you know, and everything. To me, if I'm going to wait 15, 20 minutes, I have this whole thing coated, you know, and then I'll work with it, you know, all at once. But if you get too much on there, there is a potential for you to really make a mess out of things. I'm going to find that nut while I'm doing this. I'll be right back. Alright, so let me rotate this thing a little bit. If I can figure out how to do it. Rotate. There we go. Alright, so while this navel jelly is working, I decided to check that resistor bar and see, you know, what we can find out about it. I've got my alligator clips on the negative ground lead here, and then also on the furthest. And when I was looking at the schematic earlier, you know, I said, oh, it's got 5 resistors instead of 4. No, it's tapped 4 times. That 5th resistor that was showing on the schematic is a whole nother resistor altogether. R11 down here, which is not part of the bar. R10 is the bar, which comprises these 4 resistors. So anyway, my confusion is settled. I don't have any more confusion on that. Now, the resistance, total resistance on the bar, I believe was 45K. R10, 45K ohms, tapped, 4. 10 plus 10, it looks like it may be 5. 4, 45. 4 times 10 is 40, and then a 5. So 1, 2, 3, 4. Yeah, there are 5 connectors on it. See, okay. Maybe I am still confused, but no, not anymore. Now what it is we should have a total of 45 where this red lead is, and then as I move it in, we should go in 5 points on this last one to a 10, to 40, and then to 30, 20, and then 10. All right. Come on, 45, yeah, 45. I'm getting nothing. I have nothing. Wow. Let me check the 45K. 45K. That should be on that setting there. I get nothing there. Got nothing there. It's giving me an open reading. Open. Yeah, okay. Just wanted to verify on that. Let's try the very first. And maybe I'm doing this wrong. Nothing. Nothing, nothing, nothing at all. What in the world? Yeah, I got navel jelly on my finger, but I got gloves, so who gives a dang? I got nothing. Wow. Interesting. There. So even at the first stop we had nothing. We have nothing on all of these. It's a bunch of garbage there. So it's either bad or I'm measuring it wrong. Or my ground is bad. Well, I expected to get something. Now, this is rather interesting. I suppose that bar is just no good. Now, The transformer, yeah, transformers are attached down here, grounded to this bar. There's T1 and T2. Coming down from the bar. Why they're grounded to the bar and not just grounded to the chassis. Bar, I guess. But then T2 is not, however it is. It is. Wow, that's a rather crappy looking solder joint. I wonder if this was not original, if they were. That's been replaced. Well, I guess that bar's no good. Well, I'm going to start wiping this navel jelly off. It's been sitting on there for a little while. And that's got brass on it because I found the nut. This is the nut that needs to go on that transformer. Just going to wipe it off to begin with, and then I'll get the water. Some water after it. I don't know if that did anything to the white corroded part. It definitely hit the metal, the bare metal parts. Make sure I'm not killing anything over here. I coated the other side, but I'm going to let it sit a little longer.